The trick. If all I know is the slope of a line has to be something. So let's say there's line 1 has a slope, we'll call it M1, has a slope of -3. Line 2 is perpendicular to that. So what's M2? So I know the slope has got to be 1/3. So pretty cool with that by itself. So I know what direction it's got to be going. But where does it start? It don't matter. So if I draw a line, so let's draw a line. It's got a slope of -3, so it looks like maybe this. How many lines are there that are perpendicular to this? How many lines are perpendicular to this line? An infinite number. Here's one. Here's another one. Here's one. Here's one. Hey, what about this one? Hey, what about that one? What about in between there? What about this one? What about that one? What's true about all these lines, they all have the same slope. Right? If two lines are perpendicular to another line, they have to be parallel. Think about it. If these two lines are perpendicular to this line, they have to be parallel. So all these lines have slope 1/3, but they all have different y-intercepts. That's why I need the slope and a point. So if I knew my line was perpendicular to this line, and it went through this point, well, it must be this line. It can't be any of these other perpendicular lines. It must be that perpendicular line. That's why I need the slope and a point. Otherwise, there's an infinite number of answers. I'm like, here you go. Take your pick. Do you guys get that? Slope tells me the way I go. Go north. And then you're like, starting from where? Because there's a lot of norths, right? Starting from the store. Okay, go north. Okay. Right? If you have a treasure map, go north 5 paces. You're like, from where? Shit. From the rock. Okay, from the rock. Okay, 5 paces. Great. There's some treasure. Does that make sense? Slope, direction. Point, starting place. From where? Is that decent? Does that help? Okay. So there's going to be questions that just ask you what's the slope of a perpendicular line. There's actually an infinite number of them, but they all have this slope. If this line has -3 slope, all the perpendicular lines have to have 1/3 slope. How many lines have 1/3 slope? Infinite number of lines have 1/3 slope. Up 1/3. I can do that all over the place. Maybe. Okay. Anything else from homework I can explain to a certain degree? All right. I'm going to assume that means homework is going great. Not that you're not doing it. Okay. So what we're doing today is we're going to finish up 3.7 and look at 3.8. And then we'll head out. Right? Especially depending on if I deteriorate further. You're all like having this moral dilemma. I'm going to root for him to get sick. Does that make me a bad person? I don't know. Oh man, I didn't bring my little pen. There he is. Yeah. Okay. So Gary, now's a good time for that middle. Thank you, Carrie. Okay, so here's 3.7. What we did last time was we discussed the formula that goes with this section. So the mx plus b formula is weak because I have to know b, and what's b? The y-intercept, y value of the y-intercept, right? And do I always know that? No. Right? If I have some point in a slope, I should be able to get the equation of the line. That's all I need for a line. That's all I need to draw. There's a point and a way to go from there. Then I get a line. So I should be able to get the equation no matter if it's a y-intercept or what point it is. So last time we started with, let me see if I got something I can write on. That's not somebody's paper. Last time we started with this. Can you see it yet? There it is. Good. You guys remember this? And then I said, this doesn't have to be that specific. The little subscript means a specific second point. I can pick any point on the line. So I can have one point somebody tells me, and I can pick any other point I want to. And the slope is going to be the same. Sorry. It's fantastic. I love it. Yes, Jeff. Yeah. No. Do I have liquid of some kind? Yes.
We can leave if you want.
Oh. You're so understanding. Okay. So selfless. And then I really want you guys to understand. So if somebody gives me a point, I pick any other damn point on that line, the slope has got to be the same. That's the whole idea of a line. The slope never changes. If the slope changed, what would happen? That would no longer be a straight line. It would be a curve. So that's really what this doesn't seem like that big of a deal, but that's what this is saying. The second point doesn't have to be a specific point. It can be any point you want. And then you multiply that bad boy up, and somehow, hello, this is another equation of the line. And so this guy requires us to know the y-intercept. Whereas this guy just says, any point you have, you put the x piece there and the y piece there. So this guy works with any point, which is kind of nice. Because sometimes we're going to have points that aren't y-intercepts, and I'm like, shit, I need something better. Well, there's something better right there. This, again, math people, very creative. We said there's a point and the slope. We'll call this point slope. I think my joke was it's not as interesting as Point Break. Yeah, if you've ever seen the movie, not much is as interesting as that movie. Okay, so now watch. In order to graph a line, you need at least 2 points. Blah, blah, blah. But if I'm given a point and the slope, this is the reason why I should have an equation that works, because that's all I need. Can you guys, don't say anything out loud, try to graph the line that goes through that point and has that slope. And then we're going to figure out the line's equation. This is page 37 in case anybody's looking for it out there. All right, so -1, -3. -1, -3. I'm going to start there. Slope 5/3, so I go 1, 2, 3, 4, 5 over 1, 2, 3. There's another point, so we can graph it, but this sucker's got to have an equation. Oh boy, it's semi-straight. So how do I piece this equation together? So here's the point slope form, which makes sense because I have a point and I have the slope. This will be y minus what? Yeah, because that's the y piece of the point I've got. Y minus -3 equals, yes, slope is 5/3, it's m. X minus the x piece of the point. So just to clean it up a little, I got y plus 3 equals 5/3 x plus 1. Yep. All right, and you could distribute this and whatever, so we're not going to worry about that at the moment. Yes, sir?
I just have a question on the equation. Can we do y1 equal y plus m?
Oh, you could do y equals y1 plus this. I mean, you can add the y1 over.
So we don't need to worry about this step anymore.
Sure. So you could write this, you could add the y1 over. I love it. You will see it written like this in most things. Yes?
Can we also do y2 minus y1 over x2 minus x1?
Not really, because in this equation, what can x be? What can x be? Anything it wants to be. And then the y is whatever you get when you put that value in, right? So if you put a subscript on something means that's a specific given thing. But here, I want it to have no subscripts because it could be anything it wants to be. Okay, I like it. That's why we took the subscripts off before we multiply those x's up.
Thank you.
Okay, sure. All right, maybe. So if I had this equation, can somebody tell me something about the line? Can you tell me anything about that line? I like it. That's a good, safe place to start. The slope is -2 over 1, sure. What point does it go through? Careful. So here's where things get interesting. If you look at the equation we're talking about, there it is. Y minus y1. So the y piece of the point is 3. X minus x1. -1. Since there's a minus in the equation, it's going to be the opposite sign of what this is. Look at a real quick way to see it. What makes this 0? What makes this 0? -1. What makes this 0? 3. So -1, 3. That's the point it goes through. That's another reason why we leave that y1 here. Right? So it goes through the point -1, 3. So there will be some problems in the book that give you this form and they ask you, tell me what the slope and a point is. Can't like it. So it's really kind of evil when the equation itself has a minus in it. You've got to be really careful. It's not just the number you see, it's the opposite of the number you see. Oh, shit. Because look what happened here. What was the point we went through? -1, -3. Look at the equation we got. It's got a +1 and a +3 there. Why? Because minus and negative made it plus. So when I see a plus, I knew there must have been a negative value there. So that's the negative part of the point. Maybe. Okay. So try number 1 here. So it doesn't really say to do anything with it. So here's the equation. Y minus y1 equals m times x minus x1. I told you before, you could label the point they give you, x1, y1, if that helps. So y minus what? -2 equals m, -1/3, x minus 1. So there's really only one thing you got to do when they don't ask you to do anything to simplify. You should still rewrite that as y plus 2. And then you can leave it like this. That's point slope form. Now look at number 2. What's the difference with number 2? It's basically the same problem, except they ask you to put it in that form. So try to do number 2. So you remember slope-intercept form, which is the only other form we know for a line. What's the final form? Yes, sir.
For the first example, you were saying like when like it's y minus y1 and x minus x1, so those first variables aren't necessarily defined. You can choose any point on there.
Because I know the equation of a line should be something where I can plug in any point from the line and it will work in that equation.
So we don't have to plug in points. We're just writing it like this to say.
Because those are supposed to be the places where I can put any point I want to. So those have to be,
Our job is just to get it into slope-intercept.
Our job is just to set up that equation that would be true if I put any point on the line into it.
Okay.
Yeah. All right, so let's see. Let's catch up here.
Good question.
Yes.
You said change the sign and flip something.
Oh, so today we haven't really talked about that. We talked last time about perpendicular slopes. I think we had an example earlier, but that's sounds like what you're thinking about. If I have a slope that's perpendicular to another one and the negative reciprocals. Here it was just the fact that these are both negative, so you make it plus, right?
Oh,
That's the one little thing. Here you got to go further because they ask you to put it in slope-intercept. So there's a little bit more. I don't want to solve for y then, right? What's slope-intercept form? That's y equals mx plus b. I like it. So here we start with this guy. And then we put stuff in the right places. It'll be y minus negative 3. That's the y piece. Equals 4 times x minus negative 2. Then you start to clean it up. And then you got to clean it up even further. So y plus 3 equals 4x plus 8. Subtract 3, I get y equals 4x. Careful. Plus 1. How can you check yourself? Check yourself. Put negative 2, negative 3 in, and make sure it works. When I put a negative 2 in for 4, negative 8 plus 5 is? What's negative 8 plus 5? Negative 3. So when I put a negative 2 in, I do get a negative 3 out. That's the check. So again, I want to reinforce this. This equation is the equation that will be true when I plug any point off of this line into it. So in that very first example we did, what would happen? So see that 2 points? Where the hell did that point come from? That's not the point they gave me. That's the point we got up to, right? But what should happen if I plug 2 in for x and y? If I put a 2 in there and a 2 in there, this should be true. This should be a true statement. And let's see. If I put a 2 in here, all right, let me stop. Is everybody with me? If I draw a line and I have its equation, every point I just went through has to work in the equation. That's the connection. So if I take that 2 point, 2 plus 1 is 3. The 3's would cancel, so that would be 5 on this side. 2 plus 3 is, sweet, it works, thank God. So you can check your work on these. Make sure any other point you get actually works in the equation. That kicks so much ass. It's nice to have a way to check what the hell you just did. Okay, maybe. Okay, let's see what they got over here. Oh my God. I like it. So now, if I ask you, write the equation of the line, or find the equation of the line that does stuff. What 2 things do I need to find? I need to find the slope and a point. If it's the y-intercept, that's beautiful. I can just plug that in for b and be done. If it's not the y-intercept, oh shit, I got to use a slightly more complicated formula. But still, I got somewhere to put the point, right? So try 3 and 4. want to point something out. 3 and 4 are the same problem almost. They just don't have the same points. How many points does 3 give you? For sure. It gives you 2 points you can see for sure. How many points does 4 give you? 2. They just don't graph it, right? So they're the same problem. I need the slope and a point. Well, I got 2 points. Does it matter which point you use? That's interesting. It doesn't. Of course it don't. They both would lead to the same line, right? You guys, so we're going to do it both ways, just to show you get the same equation either way. What's this point here? Negative 4, 2. I like it. And what's this point? 4, 5. Now, to get the slope, I just have to count, right? So how much do you get? You get 3 over 8. So the slope is 3 over 8. If I use negative 4, 2, I'm going to say, and then over here I'm going to use 4, 5. It doesn't matter. So if I use negative 4, 2, it'll be y minus 2, that's the y piece, equals m times x minus negative 4, that's the x piece. And some of you guys might want to give up halfway through this, but it did say simplify to slope-intercept form. Oh, shit. 3/8 times x, I'll do that part. This is plus 4 in here, right? So 2 negatives, is that cool? What's 3/8 times 4? Well, one smart thing to do is just to write the problem so you can do it on the next step. Stop right there. So I minus the negative is plus. I distributed the 3/8 through. But I didn't try to do this in my head. I wrote it down for myself. 3/8 times 4. And now I can look at it. What happens with this?
3 halves.
Yeah, 4 goes into 8 twice. So you get y minus 2 is 3/8 x plus 3 halves. And the last thing I have to do is add 2. I want to get y by itself to get it in the mx plus b form. So you go y is 3/8 x plus 3 halves plus 4 halves, 7 halves. Whew! We got a little packed there at the end, but that's 3 halves. Is everybody cool with that? And then I'm adding 2 over 1, so multiply by 2 to make it over 2. 3 halves plus 4 halves is 7 halves. Oh, shit. Some of us, if there's any fraction of the problem, you guys will just skip it. I'm like, oh. You got to power through. Now, let's try it again with the 0.45. So if I do the 0.45, what's it going to look like? Y minus 5, the y piece, equals slope times x minus 4, the x piece. You can kind of cut to the chase. Let me see if you guys are cool with this. Distribute the 3/8 through. What was 3/8 times 4? 3 halves, right? Remember that? But this is minus, so it'll be minus 3 halves. So when I distribute 3/8 through, we already did the work for 3/8 times 4. There it is. So it's just minus here, right? Okay. Now what's the last step I got to do? And of course it's 5 over 1, so multiply by 2. What's negative 3 halves plus 10 halves? 7 halves. I got the same equation. And on one level, it should be like, well, yeah, you did, Jeff, because it's the same stupid line. So it does not matter what point from the line you put into the equation. All the points are supposed to work in the equation. So it doesn't matter which one you use to build it. Yes?
How come in the other one you kind of like run the denominator through, but this one you made it a fraction?
Sorry, do it again.
Like on number 2? Oh, never mind.
It's because yeah. Number 2 is really nice because there wasn't any fractional slope, right?
Right.
And number 1, I didn't even worry about it because they didn't ask me to simplify it. But this one would have been really nice and ugly. Do you guys see that? Distribute this, get plus 1/3, then I have to subtract 2 from it. Got to get LCD. But they didn't tell me to simplify this one. That's why I didn't do it. Yes, sir.
On that one, how come it was negative 3 halves?
Yes.
How come is it positive 7?
No, this, 7 halves here, right?
7 halves, sorry.
Negative 3 halves plus 10 halves, because they're going to add 5 to both sides. Still comes out to be 7 halves. So I get the same equation no matter which point I use. I really want that to be like, well, duh, Jeff, because it's the same line. Yes, ma'am.
Does that say 5 times 2?
Yeah, let me see. Let me do it again. Let me see. Let me start from right here. So if I distribute that through, I get 3/8 x minus 3 halves. Cool? 3/8 times 4. 4 goes into 8 twice, so it'll be 3 halves. Is everybody cool with that step? Then I have to add 5 to both sides. But how do I add these two? Multiply by 2. So that's negative 3 halves plus 10 halves. And that gives you the plus 7 halves. So you get this equation no matter which point you use, because there's only one line. So it doesn't matter which point you use, you got to get that same equation. How many points on a line? Infinite number. So they all have to work in the equation. So it doesn't matter which one you use. All right, what about number 4? Has anybody done that one yet? Try that one. All right, John. So first thing here is to figure out what the slope is. How do I figure out what the slope is in this situation? No. Draw the line after you get the equation. So how do I get the slope?
Oh, the change in the y.
Yeah. y2 minus y1, so 5 minus 3 over 2 minus negative 3. Get out of there. y2 minus y1 over x2 minus x1. So I get 2 over 5. So the slope is 2/5. And now I just need a point. Well, I got 2, so pick one. Which one do you guys like the best? 2/5. That's what I heard first. So please don't get confused that the slope has the same numbers as the point. They don't matter. Okay. So now I just plug stuff in. Y minus the y piece, 5, equals the slope, x minus 2. Bring that in. And then what's the last thing? Add 5. So now I got to make it over 5. So I got to multiply by 5. So I end up with 2/5 x negative 4 plus 25. 21. Now I want to point out something real quick on that last one we did. Since they drew this line, it's easier to see. What's the y-intercept of the line we got? What's the y-intercept of this line? 702, which is better known as what and what? Make it a mixed number. 2 goes into 7, 3.5. So see how the y-intercept is? 3.5. halfway between 3 and 4? Yeah, okay, cool. So your y-intercept could be disgusting. What's going to happen when you have all these fractions running all over the damn place? So down here, look at, we got even a worse y-intercept. That'll be 4 1/5. Well, we don't have to worry about that. Really, how do I graph this? I just have to graph -3, 3, and 2, 5, and then connect them. Y-intercept is supposed to be 4 1/5. Hey, it goes through the y-axis a little above 4. That's beautiful. That's beautiful, right? Yes?
So on the test, you know how like when you find a slope, can we just graph it and find it that way?
Not always. Not always. And that's the slow way to do it. If I give you the points but I don't graph them for you, you should use y2 minus y1 over x2 minus. That's quicker. I don't have to set up a whole thing and then count. If I give it to you already graphed, yeah, rise over run. But I need you to know this equation. The y2 minus y1 over x2 minus x1. Yeah. Here.
Can you just read off the last line? Y equals what?
2/5 x plus 21/5. Yes.
Can you also solve it based on points -3 and +3,
Of course.
please?
Oh, I see. Do you want me to? Okay. Theoretically, yes. I mean, so again, just like I did up here, I did both and we got the same answer. I was hoping that you would be okay with understanding that if you did put -3 in, you would still end up with the same answer. Now, if you tried it and you didn't get the same answer, something went freaky.
Yeah, I got very close to it, but I think I messed up somewhere.
Okay, you can show me at the end, yeah.
Okay.
How would you use the formula for finding slope with just one point? You said at the beginning of class you could.
No. Oh my God. If I only have one point, I can't find the slope from just that.
Oh, I think you said something like any point.
If I'm given a point and a slope, then I should be able to find the equation of the line.
Oh,
But how many points do I always need to be able to find the slope to? Now here, at number 5, how many points did they give me? 1. But how am I going to find the slope? They gave me more information. Information? Perpendicular to that. So what would the slope be for number 5?
3 over.
Yeah, the slope for our line will be 3. The negative reciprocal of this line. What's the only thing I care about with this line? I only care about his slope. I use that and I'm done with him. You throw him to the curb. Done with you. I don't care about this at all. I don't give a shit. Right? I just know that I'm perpendicular. I got my slope of 3. I got my point that I go through. You can plug that stuff in.
It would be y equals 3x plus 1.
Let's see. So our slope will be 3 because it's the negative reciprocal. So it'll be y minus the y piece equals m times x minus the x piece. And then it can distribute, do all that stuff, subtract 1, I get 3x minus 10. Wow. So if you graph this and you graph this, they would meet at 90-degree angles. Sorry. There's so many cables at the top of this thing, I can't put it up there easy.
What happened to the fraction?
Which fraction? Oh, all right. Again, so our line is perpendicular to that line. What does perpendicular mean for slopes? Oh shit. What does perpendicular mean for slopes? Negative reciprocal. So what's that guy's slope? Negative 1/3. Now change the sign and flip it and you get 3. That's awesome. That's so beautiful. Okay. All right. I'm thinking that's all I can take, to be honest.
Alright.
Is that all right?
Yeah.
Really? If I were you, I would look ahead through 3/8. Functions. We got a little handout we're going to do next time about functions after we talk about it. Whoa! Sorry. Bless you. Oh, cough medicine or something.